A linked list is just a series of objects where each object is pointing to the next one. To create a linked list, I need to define the data structure first. I'm naming it linked node, and you can name it anything you like. It has a constructor that takes in a value and also has another attribute that by default is pointing to none. Now when I instantiate a linked node, this 2 is being passed as this value, and the next for now is none. So basically I'm creating this object with a value of 2 and a pointer to nothing. So head is that object, value of it is 2, and head next for now is none. I'll create another node with a value of 5, and to connect these two nodes, all I need to do is to assign this node to head next. Basically this connection is now pointing to the newly created node. And the value for both of these are 2 and 5 right now, and I could get to this second value by tracing from the first node as well. So basically if I do head, so head is this whole object, and go to the next one, then I reach the newly created node as well because they're connected. If I create another node, this will create this standalone node. And one thing to notice is that I'm using the same name because this is just a reference. So this is not really changing this previous object that I created. And the values for these right now, so head is a reference to this one, head next is a reference to this, and node right now is this last one. And I can connect this one by going head next next equals node. So now all of my nodes are connected, and I can do the same thing with the last node with a value 8. And I'm going to name this one tail because it's my last node, and the connection is the same as before. So node next, so node is here, next is this connection is equal to tail. So now I have these 4 nodes that are connected, and I have 3 references to these 3 nodes. One thing to remember is that these names are references to these objects. They're not the objects themselves. What I mean is that when I write node equals tail, I'm not really changing this object. I'm just saying node now points to the linked node that is called tail. So both node and tail right now point to this link node, but the values of these nodes are all untouched. To loop over a linked list, you can create a while loop and continue until your node reaches nothing or none. And I'm creating this node value because I don't want to lose reference to the head node, because if you don't have the reference here and you only have a reference to a node like somewhere in the middle, you can never find the nodes to its left because this is a one directional linked list, and we're going to talk about doubly linked lists in a minute. So my while loop will just print the node value and then go to the next node at each iteration. Let's say we want to create a linked list for an itinerary. Now I have named this travel node, but this is exactly the same as what I had as a linked node, except that instead of value, I have the name of the cities. To create this linked list manually, I can create each city. So I have city 1, 2, 3, 4 referring to San Francisco, Las Vegas, Austin, and New York. And then I'm creating this connection between each two. So city 1 is connected to city 2, 2 to 3, and 3 to 4. Now you can imagine if I had hundreds of cities, this would be cumbersome and the code would be too long. So to create this in an automated way, so let's print this out first. What I can do is I can just get the values. Usually you can expect the values to come in the form of a normal Python list, and try to convert that Python list to a linked list. One technique that I can use to make the for loop cleaner is to use a sentinel. And sentinel is just a node that we can use at the beginning or the end of a linked list to point to the head or tail. Basically, we are not interested in its value, but we are interested in the fact that this is pointing to the head of our list. So current city right now is this sentinel node, and city at each iteration is one of these strings. So initially I am I'm creating this San Francisco node. So this San Francisco node is created, and then I'm connecting current city, which was this Sentinel node, to the newly created San Francisco node. So in the first iteration, I have this portion of the linked list created. And then I'm moving current city forward one. So current city was here, got connected, and now current city moves forward, and San Francisco is current city. So in the next iteration, city is going to be Las Vegas. So travel node of Las Vegas is created, and current city next gets connected to Las Vegas. And again, current city moves forward one. So this continues until this list ends and the for loop terminates, and my linked list is created in an automated fashion. So if I print these out, I see the names of the cities. And from this point on, I'm going to use this pretty print function, which basically converts a linked list back to a list. So all this does is it creates an array and puts the value of every node one by one into the array, and at the end it just prints all of them out with this in between them. A linked list is very time efficient for deleting or inserting a node, as opposed to a regular Python list where you would need to shift all the elements left or right when you do a deletion or insertion, and it would cost you O of n. For a linked list, it will only cost you O of 1 because you only need to change the reference of the nodes to its left or right. Let's say I want to delete the Las Vegas node from the linked list that we created before. All I need to do is to remove this connection and point the San Francisco node to Austin. That way, when I am iterating over this linked list, I have no way of reaching Las Vegas. So I start from Sentinel, then go to San Francisco, then Austin, and then New York. So let's take a look at the code for that. San Francisco is Sentinel next. Austin would be Sentinel next, next, and next. So originally we did have this connection. This is basically after the deletion happened. So I have a reference to Austin, I have a reference to San Francisco, and now all I need to do is to point San Francisco to Austin, which I can do with this single line. And if I print all of the nodes out, you can see that there's no Las Vegas, and I'm just going directly from San Francisco to Austin and then New York. Inserting a node is somewhat similar to the deletion process. Right now I'm starting with this linked list, so I only have these 3 nodes after my Sentinel. And let's say I want to insert Raleigh right between Austin and New York. All I need to do is to find a reference to Austin, and then find a reference to New York, and then create the Raleigh node and connect Austin to Raleigh and connect Raleigh to New York. So let's start with the references. So Austin is Sentinel next, next. And New York, I could just do Sentinel and then 3 next, or I can just start from the Austin reference and call Austin next. So I have these 2 references. Now I need to create the Raleigh node. So I'm just instantiating the travel node with the value Raleigh. So I have a reference to this point. So currently these 2 don't exist. These connections don't exist. So to create them, I can do Austin next equals to this Raleigh node. So I'm creating this connection with this first line. And then for that second line, I can do Raleigh next equals New York. And if I just print all of these out, again, I'm starting from the Sentinel. So I'm passing Sentinel next to my print function. And I see San Francisco, Austin, Raleigh, and then New York. We can also update a node's value, or in a sense, replace it. So here in this linked list that I have, if I want to replace San Francisco with Los Angeles, I don't need to do a full-on deletion and insertion. I can just update the value of San Francisco, and I can just do it in a single line. So Sentinel next, which is the San Francisco node, has the city attribute, and I will just assign Los Angeles to that. So if I print my linked list out, now I'm starting from Los Angeles and the rest of the linked list is untouched. If I want to find a node in an automated way and then delete it, I can use a while loop with 2 references. Basically, I have one reference called prev node, basically previous node, and another one called node. So these two are always going to be two nodes back to back. So when they start, prev node is the sentinel node and node is my first node. And then in the next iteration, both of them will move forward by one. So prev node will be Los Angeles and node will be Austin and so on. Now, my goal is to delete Austin. So when node reaches node city, basically is the value of Austin, this one line will do the deletion. So once we are at this stage, prev node next is being connected to node next. And that's all we need to delete the Austin node. So if I run this, you see that there's no Austin in my linked list. A doubly linked list is pretty much same as a linked list, except that each node also has a connection to its previous node. So if I want to dynamically create the same linked list as I had, but convert that to a doubly linked list, all I need to do is to create this additional reference of previous city, and at each iteration in my for loop, connect the node that I create back to the previous node. This code is fairly simple, but it's one of those concepts that will make a lot more sense if you actually write the code for yourself, try to draw these boxes and visualize. So basically try to see what line of code is actually performing which connection. I have another function to pre-print this, and as you can tell, I have the cities as shown above. To delete one of these nodes, the process is again similar to a linked list, except that I need to take care of two connections instead of one. So I need to remove this connection that was from San Francisco to Las Vegas, and also the connection now from Austin to Las Vegas, because we have a connection going back as well. So the goal here is to delete Las Vegas. Remember, we are not really trying to remove this object. We are just removing the references to it. So right now, if I start from the Sentinel node, there's no way for me to get to Las Vegas. I go from here to San Francisco, then reach Austin, and then New York. If I try from the other way, I go from New York to Austin, then San Francisco, and then to the Sentinel. So if I don't have any references to Las Vegas outside of here, my garbage collector will automatically get rid of this because there's no references to this object. Understanding a linked list is relatively an easier concept than mastering it and being able to solve questions in a short period of time. I've left a few questions for you in the description section, so you know what you can expect to get in interviews. Try to solve them and gradually increase your mastery of this concept. Best of luck.